All right, today is our last day of notes for BC Calculus. So we'll get right into it. We want to warm up by graphing the polar curves represented by r equals 2, which is just a circle, and 1 plus 2 cosine 2 theta. So circle is easy. It's got a radius of 2, so that would be this. And then the other part, let's see. You can make a table or you can graph. I've been kind of on a graphing kick lately, right? So, all right, let's see. So pi is the period, 2 pi divided by 2. Cut that in half, pi over 2. Got pi over 4 is our angles here. It'd be a 2 cosine graph, and then you go up 1. So normally it starts at the amplitude 2, but we're going to go up 1 to 3. And then normally we would hit 0, go up 1. Normally we'd hit -2, go up 1. And finish off the last parts. There's my 3, or my 2 cosine 2 theta plus 1. If I need to do more points, I will. And I should probably have done that in red. So face 0 and go out 3 units. At pi over 4, which is not, here's pi over 4. There's not a line on this grid for that. At pi over 4, go out 1 unit, which would not be on the circle. Right there. Okay. And then hit the pole at some point. So get back to the pole. So we've got this going on right now. And then at pi over 2, -1. So face pi over 2, but go backward 1. This is really small and tiny. Sorry. And then hit the pole. Okay. And then face 3 pi over 4. Again, that's here. And go forward 1. All right. Face pi and go out 3. Okay. Maybe you can kind of figure out what this is looking like. I don't really need to know all of the points because we're probably going to be doing something with area. And what will be important are, where are these places where the curves intersect? Like what we're going to be looking for is probably the negative area, or the area either inside the petals, outside the circle, or maybe inside the circle, outside the petals. That would be pretty hard. So anyway, we just want to be able to graph something like this. How do we find points of intersection between two polar curves? So here's another set of two curves. And here's a graph off to the side. R equals 1 is the circle, so that's in blue. R equals 1 minus 2 cosine theta is the red graph. So remember, you can kind of look at the graphs and see what these points are, and you can verify by checking the angle. Like I can see that it looks like they intersect at pi over 2, right? Because on the circle, if you're looking up at pi over 2 and going out 1, but I can double check that by putting in pi over 2 for cosine and getting 1 minus 0. So anyway, I can see some of these points of intersection, pi over 2 and 3 pi over 2. I'm going to write them in. You should always double check those points, but again, I can see them. What's this point right here? It looks like I'm either facing pi or facing 0 and going backwards, so that's something to look into. And yeah, and we can solve that algebraically. I would just say though, for the angles that are right on the axes, I think it's smarter to be like, okay, this is either 0 or pi. Let's plug them in and see what happens. What is 1 minus 2 times the cosine of 0? That's 1 minus 2 times 1. That's -1. Face 0 and go back 1. So yeah, it's 0. What if I did pi though, just to double check? 1 minus 2 times -1 is 1 plus 2, 3. That's probably this point right out here. That's pi. Okay, so what are the points of the intersection? I can look at the graph. What if I don't have the graphs to look at, though? So I would be saying, all right, where is 1 equal to 1 minus 2 cosine theta? I can get some of the angles here. When is cosine theta equal to 0? At pi over 2 and 3 pi over 2. But if I'm just going off of the algebra, I'm missing that point, right? They also have that point of intersection at 0. So you have to be careful because there's another point of intersection at theta equals 0, and that's from the graph. Now the question said, find points of intersection. Remember, points of intersection are r theta. All right, so I need to figure out what r is at these values. I can see it again on the graph, I can see it, but I could also plug it in. So I'm gonna, to save time, I'm gonna use that graph. So at pi over 2, that was 1. 1 pi over 2 is an intersection. Oh, duh, you know what? It would have to be 1, right? Because the circle is r equals 1. So life is easy for this one. We won't always have a circle and another curve, though, so you might actually have to spend time plugging in points, but there are 3 points of intersection there. Okay, so we need to be able to see the graph to know everywhere that the points meet. So either you're going to be graphing by hand or on your calculator, and make sure that you always check the pole, because when r is 0, theta could technically be any angle. So even if, like in this last one, even if the points of intersection don't give you a value that gets you to the pole, like their r isn't equal to 0, obviously, then you still need to double check that and say, like, well, what are the thetas that make each curve equal to 0, and do they match up? Okay, so we're just finding points of intersection. So start off by just setting the two curves equal to each other and finding cosine. What is 1 plus cosine theta equals to 1 minus cosine theta? I can get 2 cosine theta to the left side equals 0. And I can get theta equals pi over 2 and 3 pi over 2. And we're always talking about 0 to 2 pi. By the way, we don't have to give infinitely many answers. Don't forget to check the pole. Do both pass through the pole? Not every polar curve passes through the pole. That circle, the blue circle, never hits the pole. It doesn't have a point on the pole. So, that's why I say, do they both pass through the pole? So check that out. 0 equals 1 plus cosine theta. So -1 is cosine theta. So the first polar curve hits the pole at pi. Okay, and then 0 equals 1 minus cosine theta. So cosine theta equals 1, theta equals 0. Now that's not the same theta, but remember, at the pole, r is 0 no matter what theta is. These 2 points are equivalent. If I tell you to graph 0 pi, and I tell your neighbor to graph 0, 0, and then I ask someone else to say, well, who graphed 0 pi and who graphed 0, 0, they shouldn't be able to tell me, right? There's no difference. So I'm just going to use 0, 0. Oh, sorry. So my point of intersection, or my ordered pair, can be 0 or pi. So I can have, so at pi over 2, when I plug in pi over 2, I can have 1 pi over 2. That's one point of intersection. 1, 3 pi over 2. And then 0, 0, or I could have said 0 pi as well. Okay. Second example. Set these two equal to each other. 2 minus 3 cosine theta equals cosine theta. I'm going to add 3 cosine theta to the right side. So 2 equals 4 cosine theta. 1/2 equals cosine theta. That means that theta will have to be, let's see, in quadrant 1, cosine is 1/2 when we're at pi over 3. And in quadrant 4, 5 pi over 3. All right. What about the pole? 0 equals 2 minus 3 cosine of theta. Subtract 2 divided by 3, so 2 divided by -3. So 2/3 equals cosine theta. So that's not one of our common angles, whatever arc cosine of 2/3 is. That is an angle though, right? That's doable. It's not like cosine equals 3/2, no solution. That is a solution. So yes, the first curve hits the pole. And does cosine theta equal 0? Yep, at pi/2, 3 pi/2. Okay, so both hit the pole. So if both are okay at the pole, then we can include the pole. Now the pole can be anything, right? It's 0 and arc cosine of 2/3. It's 0 pi/2. It's 0 3 pi/2. It's 0 500 million degrees. It's whatever. So for simplicity's sake, if they both pass through the pole, you can always just answer 0, 0. This will always be the answer if they both pass through the pole. Last example, when is 2 equal to 4 sine of 2 theta? Last example in this set, I should say. Get your hopes up, yeah. When is sine of 2 theta equal to 1/2? When 2 theta equals pi/6, 5 pi/6. Theta equals pi/12, 5 pi/12. You're still only in the first quadrant here. Remember when you have 2 theta, there are technically 4 answers for which this is true. So pi/6, 5 pi/6. What if you get a coterminal angle, like add 2 pi to pi/6? So 13 pi/6 would make it 13 pi/12. Add 12 pi/6, so 17 pi/6 would make it 17 pi/12. Right? So that's in, let's see, do I have that right? So we have our quadrant 1 angles, and we have our, these are still, yeah, these are still our quadrant 1 and our quadrant 2, sorry. Okay, so these are our final thetas. I was second guessing, thinking like, wait, these aren't quadrant 2 angles, but it's not that. It's that the 2 theta ones are quadrant 2. Anyway, we have 4 answers for where these things could intersect. Now it might be that I don't need all of them. Like maybe this graph probably completes itself on 0 to pi, so maybe I don't need these extra guys. But we can look at that. What about the pole? R equals 2 is a circle. Never touches pole. So there is no point at the pole where we include 0, 0. So we've got 2 pi/6, 2 5 pi/6. And I think I can leave these other ones off because this graph, if I remember our 2 theta graphs, I do believe it completes itself from 0 to pi. So done by 5. It just would be redundant. We'd be finding equivalent points of intersection there. So those are our 2 points of intersection. All right, so armed with that information, we can look at the area between 2 curves. So I need to figure out where these 2 curves intersect and which curve is which. So I think I mentioned this in a previous day of notes. If you just have r equals sine theta or r equals cosine theta, that is a circle on one side of like an axis or another. So I can see this big outer circle here. The big outer circle, that is the -6 cosine of theta. So I'm going to make a note to myself. I'm going to call that the outer. Well, no, I don't want to call that the outer because outer switches depending on where you are. Okay, so then the other one is the 2 minus 2 cosine theta. First, we have to figure out where they intersect. It looks like they intersect at the pole, but then what is this point and what is this point? We want the area between the 2 curves. So what area are we trying to find? We're trying to find, from the pole is how areas are drawn, we're trying to find this stuff. All right, so let's start with points of intersection. Since I think they intersect at the pole, I want to check that first. Do they both touch the pole? Yep, cosine theta hits 0 when theta is pi/2, 3 pi/2. So yes, and then 0 equals 2 minus 2 cosine theta. subtract 2, divide by -2, that's 1. That happens when cosine is, 0. Okay, so 0, 0. That is one of our answers. And theta equals 0 is one of our angles. It can also be pi over 2, though. So it just kind of depends on what you're looking at here. It's 0 for the cardioid curve, I think that's called, or it's pi over 2. If you're looking on the cosine, the -6 cosine curve. When is -6 cosine of theta equal to 2 minus 2 cosine theta? I'm going to add 2, so -4 cosine theta equals 2. Cosine theta equals -1/2. So reference angle is pi over 3. So in quadrant 2, that's 2 pi over 3. And in quadrant 3, that's 4 pi over 3. So let's take a look here. 2 pi over 3. Remember, imagine a unit circle right here. So at 2 pi over 3, that's got to be this angle in quadrant 2. 2 pi over 3. And then 4 pi over 3 must be this angle down here. That's in quadrant 3, right? So there's your 4 pi over. We're finding these points of intersection because they represent bounds here, right? So we want to use symmetry for area, and we have to be careful about what part of the curve the pole would be connecting to as we're finding area. What do I mean by that? It's kind of hard to see in this picture, but this, I'm going to do this in blue. You might want a highlighter or something. This is the circle, right? This is -6 cosine theta. And then I'm going to put in like green. This is the 2 minus 2 cosine theta. When you're talking about finding an area between values, I'm starting at the pole and you connect to that point on the curve. So I'm on the blue curve only until I hit that point of intersection. And on the blue curve, when were we equal to 0? At pi over 2 until pi over 3. So the first area is going to be from the integral from pi over 2 to pi over 3 of 1/2 r squared. What is r? -6 cosine theta squared d theta. And then I want to add to that. I'm not subtracting. I want to add to that the area from the pole to that beyond that point of intersection. Now you're hitting just the green curve, right? Now you can use symmetry. You can stop right here, figure out what that angle is. What would that angle be? Let's see, I'm on the 2 minus 2 cosine theta. It looks like it's pi, right? So what happens? What is pi? Let's see. 2 minus 2 cosine of pi gives me 2 plus 2, 4. And of course, I just colored all over it. So yeah, 1, 2, 3, 4. Okay, so that is at pi. I can double this area, or I can go all the way from 2 pi over 3 to 4 pi over 3. I don't think I want to mess with doubling. I think because that's just extra stuff to put in, I think I'm just going to say from 2 pi over 3 all the way around until 4 pi over 3. You're on this curve here. To 1/2 times 2 minus 2 cosine theta squared d theta. Don't forget though, so that gets you all the way to here, right? And then don't forget there's another little blue chunk here. So then I could add on an extra from 4 pi over 3 until, where do we complete that circle there? At the other angle was 3 pi over 2, right? Pi over 2, 1/2, -6, cosine squared, cosine theta, squared d theta. Now maybe I should have used symmetry because I have 3 integrals here, and this would be calculator. This would be a calculator problem. I could use symmetry too and say, I'm just going to set it up here. So I could say I need 2 times the integral from pi over 2 until, did I write pi over 3 here? I meant, excuse me, I meant 2 pi over 3. Sorry about that. Anyway, from pi over 2 to 2 pi over 3 of 1/2 -6 cosine squared d theta, not a squared there. And then I need 2 times the area of that one. Just going to save time. And then I wouldn't have to include, oh, sorry, but I wouldn't go from 4 pi over 3. So I would only go from 2 pi over 3 to pi of 1/2 times 2 minus 2 cosine theta squared. Then I wouldn't need the last part. So it would be done at that. It's the same thing. I believe the area comes out to, I've got it written down as 15 point something. But again, to save time on your video, it's just the setup that I want to make sure we have. Okay, find the area inside the 1 minus cosine theta and outside r equals 1. So even though it looks like an oval on my calculator screen, red is r equals 1, blue is 1 minus cosine theta. Okay, I can see that they don't intersect at the pole. I can also check this point, figure out this point, see what those points are. It looks like it's pi over 2 and 3 pi over 2. So let's just see. When you plug in pi over 2, you get 1, yes. And when you plug in 3 pi over 2, 3 pi over 2, you still get 1. So yeah, so that one's pi over 2, and that one's 3 pi over 2. It's important to check in case one came out to -1 or something. You want to make sure you have them right. Inside the blue, outside the red. Inside the blue, outside the red. I'm trying to get this area here. In order to do that, it's going to be, because remember, everything's from the pole. It's going to be the blue, that's the outer function. Blue, blue, blue. Let's do half of it. I'm assuming that's pi. I can double check that. It's going to be from pi over 2 to pi, the blue function, 2 of those, and then minus the red function, which is just 1, well, the area of the circle 1, minus that red part should leave me with what I want. Okay, so let's do a quick double check. If I put in pi, I get 1 minus -1, which is 2, and that's 2 units out there. So I do have my points that I need. All right, so let's set this up. We're going to use symmetry for this. So the area is 2 of the blue areas. So 2 times the integral from, let's see, are we at the pole? Oh yeah, sorry, from pi over 2, that was my starting point. From pi over 2 until pi of the 1 minus cosine theta curve squared. Don't forget a 1/2, I almost forgot it. 1/2 r squared d theta. 2 of those. And then subtract from that 2 of the, from pi over 2 to pi, 1/2. It's just 1, right? 1 squared d theta. All right. Now, again, you have the same bounds and they both have a 2 and a 1/2. So yes, you can factor a 2 and a 1/2 out and you could put it all together. I just feel safer with my own work of keeping it separate. I don't mind writing the extra stuff. All right. So again, I can find that area and I think it comes out, I've got it written down on a paper. It's like 2.785. Follow up, find the equation of the tangent line at theta equals pi over 4. So, all right, so what is this asking? We're trying to find dy dx at theta equals pi over 4. And remember, r is, we're using the 1 minus cosine of theta. So if that's r, then I can use my formula to say, I mean, if I'm allowed to use a calculator, I don't have to use that big formula that's like r prime times sine plus r times cosine. I can just say, let's put r into the calculator. So it's 1 minus the cosine of The 1 minus the cosine of, is it just theta? Yeah. And then let's find the derivative of r at pi over 4. So here's dr d theta. So I'm going to write this down. Oh, sorry. This is my follow-up point. Okay, I jumped ahead. Dr d theta is about 0.707, 0.707 we'll call it. That's dr d theta. Back to my dy dx. Sorry, I got sidetracked here. I do want my r prime times sine theta plus r times cosine theta over r prime cosine theta minus r sine theta. Okay, and we're evaluating at pi over 4. So we can use a calculator and kind of just put this in. Also, remember, r cosine theta is just x and r sine theta is just y. So you could also find, like, what are the x and y coordinates at that point. But anyway, I'm going to go through and do this trying to use just my calculator. So this might be a little tricky, but I have my r, right? So let's see. Math 8 theta r evaluate at pi over 4 times the sine of pi over 4, so times 1 over radical 2. I guess I didn't need the times 1 in there. Plus r cosine theta. So let's see, 1 over radical 2, so plus r of pi over 4 divided by radical 2, because that's the cosine of theta. That's the numerator. And then, and then I'm noticing those are quite similar. And I have divided by hold on a minute. Oh yeah, okay, sorry. Divided by, I thought I didn't take the derivative of the first part. Divided by this number again, times the sine of, or times the cosine of pi over 4, so divided by radical 2, minus r of pi over 4. It's more trouble than it's worth, isn't it? Just typing it in. Oops. Oh, what is that? That's r divided by radical 2. Oh, let's just hope that this all got typed in correctly. Coming out to, oh, look at that, 2.414. And then write the equation of the tangent line. Oh, we still need a point. Let's see. X is r cosine theta. So I'm going to come up here and delete a couple of things. I don't have to go through all that typing again. Delete that. Delete that. R of pi over 4 times cosine of pi over 4. There's x. And y would be the same thing, right? Because sine of pi over 4 is the same thing. So we have y minus 0.207 equals 2.414, should probably say about equal to, x minus 0.207. Oof, that was a lot. Okay, the last thing to learn, arc length. We're still on polar curves. If we're talking about distance, we're still talking about arc length. So this should look pretty familiar, kind of similar to our other arc length formula. The integral from alpha to beta of the square root of, this is important, r squared plus dr d theta squared, d theta. In parametrics, it was like x prime and y prime. Here it's r squared and r prime squared. So if we have r is 2 minus 2 cosine theta, the arc length would be the integral from 0 to 2 pi of the square root of r squared, 2 minus 2 cosine theta squared, plus what's dr d theta? It'd be positive 2 sine theta squared d theta. And if we type that into our calculator, I have this written down ahead of time because I'm worried my video is getting long. Apparently it comes out to 16. Okay, so a couple of things to memorize. We will be practicing and studying and reviewing from here on out. But first we have to take a nice chapter 10 test where we will practice all this stuff first. Okay, that's it.